There we go. Hello. Okay, I haven't streamed in a while, so you'll have to excuse me if something's off here. I was about to stream without audio. That wouldn't be good. Yeah, so it's my last week of vacation. Been out for a couple of weeks already, and I've been thinking about like we built this. Where is it? Impact. So we have this Impact React project or Impact project, which comes off a lot of recent experiences building complex applications. And it's very much like tied to this mental model that your application is components. That's like how you think about what your application is and how it's structured. It's components. And what Impact does is kind of take recent developments in like signals and also provides like a scope to your state store, because current solutions, they typically have like a single state tree or thunks or something like that doesn't really give you a proper scope for the store. So for example here, I'm gonna fix that soon. So for example, here we have the counter store. It's a function, kind of like a hook, and you can expose signals there, but you can also like define variables and write logic and all of this stuff, run subscriptions, disposal, everything, which is important. And then you can also like scope these stores to specific component trees, but it's very much like kind of adding a controller layer to React, where this controller layer isn't part of the reconciliation loop of React. It's more of a reactive layer, funny enough. React not being reactive. Yes, but then there is this other perspective where if you think about components, like if you start with React, a component can do pretty much everything. It can do UI, of course, that's like what it's designed for, but it also has state. You can do like layout effects. You can deal with data fetching. You can create instances and dispose of them, even though there's limitations to this, like create instances of like other entities from other libraries and stuff. You can do subscriptions and you can do routing, like you can do everything in components. But then the primitives of a component isn't like add their scope to the component. That's the first thing. And then it's how you deal with complexity within these domains. The component primitives being scoped to component becomes like increasingly hard to deal with. So what we do is that we start externalizing certain things. So we might externalize data fetching, like with React Query or whatever. And then we might move the state management outside of the components or share it with components. And you might put the routing outside of components, like you do this state first type of routing, not like inline in components. And then you put like the creation and disposal of like, for example, if you want to do use the OpenAI SDK, for example, you do new OpenAI outside of the component instead of inside the component. And then you have the subscriptions. Maybe you start doing those. The point is, like at some point, your components doesn't do much else than actually dealing with UI. And this depends on the type of application and the complexity you're managing. And then the question is like, what if you flipped it around? What if React and its components wasn't the thing you think about as your application? It's something else that is really good at dealing with all of these kinds of things. And then you kind of put the UI and the layout effects outside of your application, which would still be React, but React only derives UI from this other application layer. and deals with like it would still like it can still have state and stuff, but that state is related to the layout and the elements, like building the UI. It's not related to your actual application. And I've had this school of thought for a long time, really. But then it's been like really hard to. It feels black and white. Like some people really understand this concept and can relate to it, and I guess it's based on their experience. But then you have this other school of thought, which is like, no, you have your components, and then you can like externalize certain things, but it's all about the components. And I think I've been drawn between these two things because it does make sense that like the components, they do represent UI, so it's a really good hook for understanding how an application works. But what happens is when you start like the structure of your state management and logic differs from the structure of your UI, meaning that you start centralizing state in different parts of the UI or different parts of the component tree. There's something about like navigating a code base like that. It's really, really difficult. Even just hooks, they're kind of like just all over the place. You don't really know where to put them. And it becomes very decoupled. Everything just becomes very, very decoupled. And you want your UI to be decoupled. You want your components to be decoupled so you can compose them. But your application, you don't want that to be decoupled. You want that to be tightly coupled. So it's easy to navigate and reason about how it all works. Wow, I tried to do a stream yesterday and I just couldn't find a short way to explain these two schools of thought, or like the difference between thinking these two ways. But that's it. Like components are highly decoupled. You want them to be decoupled. And you can see challenges with that using a context, for example, because you never know consuming a context if the context is available, right? Because it's decoupled. But the funny thing is, like, context is more about state management than UI. So, there's just some fundamental iffiness to React for me. But anyways, this other type of layer, that would be strongly coupled. It wouldn't, yeah. So you would very easily be able to navigate that. Okay. If I ever create like some kind of introduction to this experiment, that's going to be the core of it. Decoupled components, coupled logic. Coupled state and something like that. Anyways. So what I always do when I play around with APIs for state management is that I'm using this family Scrum app where I kind of already started playing around. So the previous approach uses like an older version or concept from Impact where you have like this global context, for example. So you can see this is kind of like a store where you're able to like compose these different hooks kinda, and we're exposing them here. And this is fine, right? But it's still like a decoupled thing. You don't know, for example, we have the app context. The app context is decoupled from the global context, and do we have the dinners, the groceries context is decoupled from the app context. So you don't see how they're actually connected. So it's hard to reason about how the logic and state and everything kind of comes together. So to choose a different like layer for state and logic, other than like components, the only thing that really makes sense to me is like how do you compose things together in JavaScript or TypeScript? And it's classes, right? You have a class, and that class can reference nested classes and so on and so on. And that's really how you couple things together. It's using classes. Like you could like get around classes, like using some other kind of mechanism. Like you could use some kind of functional, like something like this, but I don't think it makes sense because it's like it's stateful. That's the reason we have that layer. It's to manage state primarily, and then everything around that state management. And that's what classes do really well. And then you have the aspect of like explicitly making things private and public and all of that stuff. So at least for this concept, it's about classes. And the way it works is that we have something I call the app initializer. And the reason I have an app initializer instead of just the app as the front class is because I consider in the family Scrum, you have this dashboard and you can really only use the app if you're signed in. So the app initializer is about like dealing with your authentication. Are you actually authenticated? And if you are authenticated, then we instantiate the app, which is the dashboard and all the other functionality. So we're going to look at that shortly. And then we have the app itself, which deals with some views, which are the different views in the app. You have this version management thing, and you have a camera in that app. And this is stuff I've taken currently from the global context. So the next thing we're going to look at is authentication. But to kind of take a look at how this actually looks like in terms of state management. So here we have a view definition. So views are basically a custom router so that you can like navigate into things. You pop out of views. It's because it looks like a native app. I just call it views. And it doesn't really need a router. You don't like, it's not an app where you actually navigate to pages and you want to kind of, when you refresh, you should still be on that page and so on. It doesn't really matter. Oh. Oh my God. So what we do here is that we create, I'm just going to make sure this is big enough. I think I can make it even bigger. Yeah, sorry about that. So this, like, I'm just calling it ratchit for some reason. It only has this thing called, like, primarily this thing called create signal. And what you want to do with these signals is that they are plain values. But they're observable by React. And what's nice about this, like what you would do immediately is compare this to MobX. So let's do that. So first to explain this signal. This signal returns a value that you can get, you can set it, and you can also update it. And this isn't as nice as MobX, right? With MobX, you could just use it. Now, the problem with MobX is that it's a different paradigm than React. So React wants like unique values, kind of immutable values. So when a value changes, you should change the reference of the value. So these signals works exactly like that. It's almost like use state, right? And you use these signals just like use state, except that they like trigger a notification to React when they change. So that's one thing. Another thing is that MobX uses proxies to do this. And proxies isn't really nice to work with, because when you like debug them and you try to pass these values to third-party libraries and stuff, you can get into issues. Another thing is that MobX needs to, by default, protect the observables, so that you have to define these special actions to actually change the observables. And that is because even though you would make like a certain observable private in a class, you would still maybe be able to consume, like you wouldn't be able to change the observable value itself, but you would still be able to access the observable using a getter or whatever. And then you could still, like, if it's an object, you could dot into it and you could just change it. And that would trigger a notification and something in the UI would change. So that's not possible here. When I make these views private, they cannot be changed unless they're changed inside this class. And even when I do, if I would do like get views here and I would return the views, you could change them as much as you want, but it doesn't actually trigger any notifications, and it's kind of like Redux in that sense. So it's way more compatible with React. But what we're doing here is that instead of like impact React, which is doing this like dot value thing, since we embrace this object-oriented class layer, we use get, set, and update. That makes sense in a class world. And what's really nice about that is the drawback with React is that when you deal with arrays and objects, you have this like really horrible spread. Like when you update values, you have to do a lot of spreading and slicing, and like it's just horrible. But under the hood here, these signals are using immer. So when you call update, you can actually use the normal mutation API. So immer is like a temporary proxy for a value where you can use the normal mutation APIs, which makes sense in this world. But the result of this is still like an immutable value that React expects. So that's also really nice about this. Now, I think the biggest problem with this is that you have two completely different paradigms. You have this object-oriented class-based layer for your application state and logic and everything. And then you have this functional declarative components using functions. But I think that's better than trying to, oh, let me fix the camera. That's better than trying to squeeze, like there are two different problems, right? Dealing with UI and dealing with state and related logic is two different problems. And I think a functional declarative approach, of course, makes a shit ton of sense for UIs. But then this object-oriented approach makes more sense for managing state and related logic. And then the cost is that you have to flip between them. But they're just tools, right? Paradigms are tools. Yeah, so that's kind of the argument there. Okay, so let's, maybe we can look at the other ones. So version looks like this. It has a signal called hasNew, which we expose publicly so that you can observe it. And then during its initialization, we go and grab the current version from local storage, and then we set hasNew to true if there is a new version. And then we have this private fetch version. Now, another aspect of this is like, how do you expose this to the components? And what I've learned building, like being part of startups and building these kinds of applications, is that you just want to build the app. You don't want this rigid, complicated testing paradigm for your application. Because there are really two very, very important things that you need to test. And that is when you have a function that takes some input and produces a variety of outputs based on that input. Like, it's hard to reason about how should I put this? Like, the logic for producing the output is very complicated. Then you want a unit test for that. given that this function is synchronous, that's a really good case for unit tests. And it doesn't have to be synchronous. It can be asynchronous, but it shouldn't have any dependencies. That's the thing. Because if you get into dependency world in unit testing, it's not really unit testing anymore. It starts becoming integration tests. And integration tests is a fucking mess. Because you have to introduce so many concepts. Like, you have to do mocking, you have to deal with asynchronicity typically, like you're kind of forced into it because all apps has some level of asynchronicity to them. You probably have to introduce interfaces with the classes so that you can, like, for mocking or whatever purposes, and all that kind of stuff. But on the other side, you have end-to-end tests. And this is like, the way I think this works the best is if you have an application in production, you have a separate production environment called like Next or something. And before you actually merge to production, like your main branch, you merge into this next branch. And whenever you merge into that next branch, you run a set of like end-to-end tests, critical paths. Like, what's the most important functionality in your application? And then you write an end-to-end test for that in production. But it's not like main production, it's next production. Maybe you could have like staging, like database and all of that, but I think it should be production, because what you can also do with this next environment is to invite users in there. You can give users access to that next environment, so they're always on the bleeding edge. And when you do that, you'll capture like changes to the app. If any critical path is affected by changes to the app, that will be caught. Like, you won't eliminate all kinds of bugs. But the problem is when you have critical bugs, or your critical paths that leads to like your analytics and not analytics, but your metrics that affects like the success of your startup. That's the kind of stuff you want to test, right? And there will always be bugs. And the point is, you don't want to go around spending twice as much time building a feature because you have to write integration tests for it. And every time you try to fix a bug, you have to change and verify the tests. Like, it just takes too much time, at least in my experience. But then you have these isolated, no dependency, input, output things you can do unit tests for. And then you have the end-to-end tests. And that is a good coverage, in my opinion. And what it also does, it helps with the developer experience. So in this case, when we actually want to consume this thing, let's do app initializer. So what we would do here is I'm just thinking about how we would, so maybe we could do, or maybe we could even put it here. So static, oh, maybe we could even have it on the, oh, that's interesting. So what you could do here is, like, when you create it, you would have like use app or something. And then that would, sorry, I started thinking about something else there. Let's just do it very simply. So you would instantiate it, right? So you have app, new app initializer. And then if you want to use this in a component, you would just have like, and then you would have observe. And you can just start consuming stuff. App.count, whatever. And this is such a big deal. or you would have to like manage contexts and again like having interfaces and all of this stuff. But just being able to consume the thing directly also makes it a much better developer experience. And then what you would do is like, based on certain states, you have access to certain things inside your application layer. So in this case, we're going to explore like authenticating. So you only have access to the actual app instance if you are authenticated. So that means what you would rather do here is you would have like initializer or something, app initializer, and then you would do use app. And then if app initializer is I'm just doing this very simply, then you would have app initializer dot app. Right? So you have to because this is TypeScript, you only have access to certain things in certain states. So you would use hooks to access certain parts of your application layer. And then you would probably throw an error or something if you're using that in the wrong component that doesn't actually have access to it. Maybe there's a better way to do this, because this is a problem with context in general. Like now we're not actually using context, but it kind of is the same problem because of the components being so decoupled. Like you have these isolated components somewhere, you have no idea where it's going to be composed in, and you have to make sure that it's composed into the tree where this state is actually available. I did play around with something which was kind of crazy, where I would do like render equals observe, and then you can actually say discount, for example. So you would actually tie these classes to their or you would tie the rendering of that state to a specific component. So you kind of mix them, but I don't think that makes sense, because you always, like, UIs are insanely complicated. There's a reason why we want the couple components, because UIs are insanely complicated. And if you did this, you would still want the couple components to access this state. So I don't think there's like a way around that. Firebase here. Oh my god. Types. Okay. Let's see. I think we're gonna move Firebase. Let's do Firebase first. I don't think it's like that much. Get auth. Yeah, I think it's not that bad. It looks bad, but it isn't that bad. So let's just do it. Let's create a folder called Firebase. And it has like an index.ts file. It had a types.ts file. And it had converters. Some of these, we don't need to change converters and types. You can just grab them. Let's see. I guess you can't see the files I'm working with here, but converters, let's just copy them. And then we have the index of Firebase. So we're going to refactor that. So basically what we're going to do is export class Firebase, and we're going to have a provider here. We're going to initialize the app. All of this stuff we're going to okay, let's just take each one of them and let's make them private. We're gonna make them proper private. So if you don't know the difference between private and this, private is just a typing thing. So you can still access, like if you do Firebase dot, you won't have provider there. But if you do this, you can access the provider and you can actually do stuff with it. But if you use this, which is a private field, I think it's called, you can't access it at all. So that's really the proper thing to use. So we're going to do that. And then we're going to have auth in here, which will be this app. So this needs to be done in the constructor. This also needs to be done in the constructor, but these two can be done in here. And it's kind of funny because like one of the early iterations, actually the first iteration of like taking our learnings at Code Sandbox for the new editor was to do a class-based approach for the actual state management and related logic. And the reason is we wrote a lot of this code in other, like in the VS Code extension, in our pitcher process, which is the development environment process we created. And we write other languages, like Rust, for example, which is also, like, I guess some people get angry. I don't know if you call it object-oriented, but it has like structs. It's kind of like classes. Like if you squint, you think in like an object-oriented manner. I guess depending on what you're building. But yeah. And then we have, let's see. Yeah, so this is also, let's see, I think this, yeah, get family docref is, we can use, that's a method. This dot firestore. I guess that's like a method, so let's put that on there. And then we have the constructor for this, which would use these two things. This dot auth and this dot app. And then we have all the other methods. So let's take a look at that. So I like to, with Firebase, I like to create like my own abstraction over it, and not use all that low-level Firebase stuff inside my actual app. I think it's very confusing. On off. Where's that coming from? Oh. I guess we want to do this. Yeah, you know what? We're gonna do. Oh yeah, it's for the typing. Yeah, because on auth state change takes like an auth instance as its first argument, and then to avoid like writing the typing for this, I just did. Let's put that first, just to kind of show that it's a little bit special. Oh, interesting. Here we have all the collections. That will be something we have up here. I'm actually not sure if these are public or not. Oh, interesting. Yeah, so this is the thing I like about the one big negative thing for me with having an object-oriented like class-based approach is like the this keyword. As you can see, maybe, yeah, this is a good example. So when you see how we build up this Firebase thing using just a function, like you don't have anything explicitly private. They're implicitly private because they're like internal to the scope of this function, right? You can only access the internals of this function using the returned access points or API or whatever you want to call it. And what's nice about that is you don't have any dis reference. You can just, in this case, Firestore can be accessed anywhere in this returned API, right? You don't have to consider the context of this method to access Firestore. You just close over everything, which is really, really nice. But it is implicit. Yeah, it makes me think. Because I wonder, like, why are these contexts decoupled? Are they decoupled because of... They're not decoupled because we're using this way of defining them. They're decoupled because I choose to bind them to the component tree. But what if I don't bind them to the component tree? So you wouldn't use things like use global context. You would still use... Oh, yeah. Yeah. Okay, we're gonna play with something. Because the funny thing is, like, if we remove a lot of this stuff. So if you compare a class, my class, to just a function, create my class. Well, not my class, but create, let's call it something else, foo class. And then create foo. Like if you compare these two, so you want something private, right? You want a count of 0. You want that to be private. Well, let's just make that count 0. Now it's private. And now you want to increase that count. So you add a method. And then you say this count plus plus. Oops. And here, what you would do, you would just return increase, and then you would say count plus plus. What other things do we have? So you wanted to, like, based on some state, you want to instantiate something else. So maybe you have a bar. So you have like a bar class. Bar class. Right? And you want to instantiate that as soon as the count hits. If this dot count equals 3 or whatever, you say this bar equals new bar class. But then you have function create bar, which returns something. And again, you just do let, what was it, bar? Yeah, and I guess that's kind of the thing that's also nice about classes. It's like they just have a reference on its own, while these functions, they don't really have a reference by their definition. Like what you would have to do is you would do like return type of create bar. Like you would have to do that to kind of type them. Or you would have to explicitly create a type for them. But that's kind of the thing you want to avoid, right? You kind of just want to lean on the language and the functions, and it can just infer the return type here. So maybe what you could do is like you would rather say type bar equals return type of create bar. But anyway, so if count equals 3, you would say bar equals create bar. So like there's nothing you can do with a plain function that you can do, or there's nothing you can't do in a function that you can do in a class. Yeah. And even here, like create bar might have a disposer. So you call that dispose when you kind of like remove the bar, for example. You make it undefined again. And then you dispose of anything in here, just like you would dispose of a class. And I do wonder why, like if you think about JavaScript, it didn't really have classes. And I vaguely remember like discussions like this. Even like we had object create, I remember, which was called a mistake for some reason. I think that, yeah. So I think classes are like internally very optimal. Like if you add methods to a class, those are part of the prototype. While here, when you, here, you always have a dispose method created every time. But the point is like you don't, that's not a real concern in web applications, at least. Like in what we're doing, we typically only have one class for each like concept in the UI. You wouldn't have like thousands of instances of a class. In other applications, of course you would. But yeah, I wonder. Yeah, it's very interesting. Like I think that's what I can't decide on. It's like even MobX. MobX was created for a class-based like architecture paradigm. But you don't have to use MobX with that. Yeah, I'm trying to think. The problem I'm really trying to solve here is to make the components just deriving this other application layer that which is tightly connected, that you can easily navigate. And it doesn't like technically matter if you do classes or this kind of thing, at least for what we're doing. It's just a question of like, what do you prefer? And you could argue like these things are much closer to hooks, so it's a paradigm much closer to React itself, so it's less of a mental leap to use them. But still, if you have developers that are used to class-based, like object-oriented paradigms, then this is like a stretch, maybe. It's very interesting, but it is much cleaner because you don't have this reference all over the place. I have to think about this. I really do. I really do. You also have the aspect or the perspective of like IDEs, like how well do they help you? One thing is things like rename symbol and stuff that will work just fine. But then you have like these navigation tools, like jump between classes, and you also on GitHub you have like these nice definitions on the sidebar. Yeah, it's really, really interesting. Like, because how would you actually, and this is the really bad thing about classes, is this thing. Like, I think, like, if you do this, you can still, oh, sorry. If you do this, you can say, this.firestore, right? So you have to make them arrow functions, which I guess is fine. But you have this thing all over. Oh, yeah. I'm really curious what I would do here. Because I would create like create app initializer. Or even initialize app. Initialize app. Yeah. And then I would just like create authentication handling here. Like I would probably how does this authenticator work? I think it uses Firebase. Yeah. Yeah, here I even do this. Yeah. Yeah, because it uses Firebase. So we would create like let's just look at some code. So we would have Firebase, which would be create Firebase. And then we would have authenticator, which would be create authenticator. Now the thing that would be different here is we have global context, and then we have, let's see, app context index. So here we have, here we provide the app context after we've done the authentication, but that wouldn't happen here anymore. We would rather do that inside the app initializer. So yeah, okay, let's write this out and see how this looks. So what we would probably have here is like the state of the actual app, in the sense that are we authenticated or not? And as part of that, what is this authenticator? What does it have? Global context. I call it authentication. Sorry, authentication. But this is, yeah, but this is interesting because this is another. Okay, this is interesting because the bad thing about classes is like you have to reference this all the time. But the good thing is that everything is kind of flat, right? And you have this very organized, like here are the properties, here are the methods, and you kind of expect them to be there in a sense, or where they are. But here you mix everything in this single scope. Like here we define some variables, then we do some subscription to clean up, then we just define like a private function here, and then at the end we actually return the public thing. So there's no way to like set aside the private functions, I guess. What's interesting though is that you can actually do this, and you can actually put that after the return statement. I wasn't aware of that, but you can actually do that because of hoisting, which is very interesting because that means you really clean up the stuff that's actually relevant. And these are like considered more helpers, right? Create authentication. Anyway, so authentication, what did it expose? That's what. Yeah, so it just has some state. And what we would have to do here is that we have to make the app available. So this app context would have to be created here instead. The question is, how would you actually do that? So what I would probably do is like you have the authentication state, and then I would probably have a signal. Like you would have state here, which is like just a signal, and then you would have the authentication state. Like there could be other things here as well related to initializing the app. But basically what you, okay, just to get to the point here. So what you really want to do is that you want to have this state of initializing the app. And when the app is actually initialized, then you would, so you could maybe check the authenticated. Then you would say status is initialized, and then you would say app, create app. You would pass it Firebase, and all is good, right? And then you would say get state, return. Oops. In this case, state.value. Yeah, and status initialized, or maybe authenticated. I don't know, whatever. Unauthenticated. But then you will have to like subscribe to the authentication. So you would say dispose on authentication change or whatever will be authentication. Well, I guess in this case it's just a signal, so you would do like effect if authentication dot status equals unauthenticated. You would like change this state to unauthenticated or authenticated and like create app. Like this looks messy, but this will be just fine. It looks horrible right now, but this will be just fine. So maybe this is really the thing I'm after. I think I'm gonna stop the stream because I don't have that much time, but this was interesting. So what you could do is like you could have set get app state authentication. I think. Could you do this? Yeah, you could do this, and then you would have, well, no. Yeah, no. Yeah, I hate this when you kind of have an initializer and then you have decoupled, like where it changes, kind of. Kind of annoying. Anyways, doesn't matter. That's just how it is. It would be the same in the class-based approach. Like you would do use the authentication to figure out if you can mount the app or not, or like create the instance of the app or not. And then you would listen to changes to the authentication to figure out if you should like dispose of the app. Yeah. You know, personally, I would prefer writing things like this. But I do understand that some people would prefer classes. It's almost like it would be so interesting to have a library that allows you, like, it is exactly the same thing you do, but you can choose your paradigm. You can choose if you want like this functional approach or if you want to do a class-based approach. The only difference is really the type of signal you create. You know, you could even argue that the signal has do we have, so when you where do we have it? So for example, version here, like currently it has like a set, get, and update, but we could also have like dot value. It could still have dot value. And then you choose your paradigm. It will be like, even as like an educational thing, it's so interesting. Like, I don't care if people use these things. It's more like emphasis, like you can do like very educational content of like writing in text and being very detailed about like pros and cons of different approaches. But if you create a library that you can actually use to build something on your own, I think that's way more educational. But the main point, okay, so there's two takeaways from this stream. It's one, the core thing I'm trying to convey here is that you want components to be decoupled and you want state and logic to be coupled. Because components are like, component UIs, they are literally composed together, while state and logic doesn't have that same composability nature, right? You don't create a lot of different functions for changing state generically and then you compose it together. You have this very rigid state and related logic. So that's one thing. The other thing is there's two ways to express that mode of thinking. It's using classes and it's using just plain functions. And the only thing we really need is create signal to kind of make sense in both worlds. So in the class-based version, you have set, get, and update. While in the functional world, it doesn't make that much sense to use like set, get, and update. It makes more sense to have value, dot value. But funny thing is that you can still point to signal dot value, and then you can do this. You can give it a function instead, and then you get the current value here. And you can do the same kind of mutation thing, but maybe you shouldn't do that. Maybe when you opt into that functional world, you kind of opt out of the mutation world. Like you're much closer to React and you think more React. Hmm. Yeah, it's interesting. You could even argue that you could even argue that signal should be. No, we can work that way. No, sorry, my bad. Okay. Anyways, I'm gonna stop the stream because I'm done thinking for now, or I need to do more thinking. But yeah, this was nice. I'm gonna write this down and then I'm gonna play more with this. That's for sure. And then we're gonna actually refactor this app to kind of see how it looks. But it makes me think about the impact. I think maybe. Yeah, because like with Cerebral and Overmind, there was never any, like, that was always the idea behind it. You think about Cerebral and Overmind as your app, and then you have this view layer being React or whatever that just derives the state and presents the UI. And that mental model, I think, based on the feedback and also from like professional developers, is that that mental model is much simpler than trying to intertwine your UI with all your state and logic. And when these structures starts to diverge, it becomes like hellish to understand how the application actually works. Okay, cool. But yeah, thanks for hearing me out, and bye for now.